Hello, welcome back. So our unit that we're going to begin here is a really short unit if you want to measure it in terms of worksheets. It's only got a few sections in it, but it's a really important unit and it's one of my favorites. It's going to bring back a whole lot of factoring, so you're going to, if you're one of my students, you're going to be very happy that I tortured you with so much factoring over the last 6 months. Alright, so today we're going to be simplifying rational expressions. And we're going to be multiplying and dividing rational expressions. So rational expressions is a really fancy way of saying fractions. But because we're in Algebra 2, our fractions are going to look a little more complicated than like your 5th grade fractions. So let's take a look here at number 1. Old question, if I had the fraction 4x over 4y, that's not reduced because 4 times x, 4 times y. Any products can be cross-canceled in a fraction, so here the 4's would cancel out, and then we'd just be left with x over y. So here for number 2, as far as cross-canceling goes, 3 over 5, nothing reduces there, but x squared over x to the first, one of the x's would cancel, or you could use your exponent rules that says 2 minus 1 is x to the first. So 3 stays, and then we just have x to the first left in the numerator, and then the 5 will stay. So that's the reduced version of that. Now here's some new topics. This is a polynomial that's been factored. It's written in its factored form. And all of these are multiplied together. So the rule is if you have product over a product, you can cross-cancel any terms that show up both the numerator and the denominator. So I look through and I see that here's an x plus 3 with another x plus 3 that will cross-cancel. And then keep looking, x plus 4 and another x plus 4 will cross-cancel. And that's going to leave us with the expression x minus 4 in the numerator over x minus 3 in the denominator. Now, when children first learn this lesson, they have this direct urge to cross-cancel these x's. And my answer to that is there's not an x in the problem. There's an x minus 4, and then there's an x minus 3. But there's no x. So unless they're twins and they're multiplied together, they're written as products. You cannot cross-cancel anything unless it's an exact twin set. So here, right now nothing is going to cross-cancel, even though I know some of you are certain that this is going to cross-cancel. The problem is there's not just an x squared in the numerator. There's an x squared plus 5x, and then down here there is an x squared. So what we're going to do is up in this numerator, there is a common factor of x that we could take out. So what if I rewrote that numerator as x times x plus 5? So now it's a product, right? This is like x times x plus 5. But I haven't done anything with that denominator yet. It's still x squared. So there's no x plus 5 to cross-cancel, so that's going to stay. But remember, this is x to the first over x to the second. So one of the x's can cross-cancel. So one of the x's is going to go. There's still an x down here, though. And that leaves me with x plus 5 in my numerator. And then now I just have an x to the first power in my denominator. So again, these x's do not cancel. There's not an x in the numerator. There's an x plus 5 over an x. That's your simplified answer. And that's probably the hardest part of today is to remember what cancels and what doesn't. So you're going to see me put polynomials, things that have addition or subtraction signs, in a group of parentheses, so that way we don't have that incorrect urge to cross-cancel things. So here at number 5, right now I have x squared minus 4x minus 12, which obviously there's no twin to that, and there's no twin to this either, but what if we were to factor those? So I'm going to first factor this numerator. That's an old factoring question from last semester, and we reviewed it again this semester. This is going to factor into x and x, and then multiplies to negative 12, but adds up to negative 4, and think of negative 6 and a plus 2. Now don't rush through your factoring on these questions. A lot of kids go too fast and then they have problems because they don't factor them right. X squared minus 4, that's our difference of two squares pattern, so that's x plus 2 times x minus 2. So now that everything's written in its factors, I look through for any set of twins, and I notice x plus 2 can cross-cancel from the numerator to the denominator, and we are left with x minus 6 in the numerator over x minus 2 in the denominator. So again, this is a number, and this is a number, and there's nothing that's showing up twice, so this is the final simplification. Alright, this next one. 5x squared, this is a monomial. I'm going to put parentheses around it, but monomials are a little tricky because you can break them up into a series of products. Like, instead of x squared, I can write it as x times x. So if you'd like to do that, you sure can. You can write it as 5 times x times x. Sometimes kids like to see it that way, and then they can pull off pieces of the monomial when they go to reduce. But this denominator, Right now it's not very pretty, but I think I can factor some terms out of there. So there's a common 5x that I could take out. So let's go ahead and write that numerator as 5 times x times x. I think that might help some of us. But that denominator, if I factor out a 5x, now I have, let's see, a 2x plus 3 left over. So surely there's no twin to the 2x plus 3, but there is a 5, and there is an x. So look at what we're left with. We are now left with x over 2x plus 3. And again, 2x plus 3. It's the entire term, so unless the whole thing's canceling, it's not going anywhere. Okay. So, this is kind of a weird question. X squared minus 9 factors into x plus 3 times x minus 3. And then 2x plus 1 does not factor, so I'm just going to write it with parentheses around it. I don't see any twins anywhere, so that's actually my final answer. If this ever shows up or you get through your work and you're like, okay, well, that's all I can do, don't bother foiling it back together. Leave your answer in factored form. That's a lot easier for me to grade. It's also a lot easier for you to notice any mistakes as you're going through your work. So leave it in factored form. I'm really not going to give you a question where nothing cancels. That seems like a waste of your time, I suppose. Alright, so here. Careful, a lot of kids are going to want to cross-cancel these x squareds, but this is a number right now, and so is this. So we're going to have to write them as product, which means we have to write them as factors. So let's factor this numerator carefully. So x and x, that's the easy part. And then I got to multiply to 24, but add up to negative 10. So how about negative 6 and negative 4? It's worth you taking the extra like 12 seconds to double check your factoring, because if you factor these wrong, you just messed up the rest of the problem, so that's a bummer. Alright, x squared minus 4x minus 12. X and x. How about negative 6 and plus 2? And it doesn't matter the order you write them down in, because this is all one big fraction, so if I see a set of any twins I can cancel, let's do that. And a do. So we are going to be left with x minus 4 over x plus 2. And again, nothing cancels here because this is a term and this is a term, and they are not twins, and therefore they don't go anywhere. Alright. So that's our simplification. But let's talk about some operations. So back when we were multiplying fractions together, back in like 5th grade, your teacher probably taught you a couple of methods. He or she taught you to cross-cancel and then multiply together. And then maybe they talked about just multiplying together and cross-canceling at the end. And for little kids, it's easier if they cross-cancel at the beginning of the problem because they didn't have calculators, so, you know, working with smaller numbers was a lot easier. Turns out for algebra, I personally think it's easier to cross-cancel at the end of the problem. I think we should smush it all into one big, ugly problem and then cross-cancel the terms, simply because you're going to have monomials, you're going to have x's, you're going to have y's, you're going to have factors, and there's just a lot going on. So it's actually easier if you just push it all together into one fraction and then cancel at the end. I notice kids who try to cross-cancel here and here and here and here, they lose track of what's left over, so that's not really worth it. So first thing I want you to do is push this together, I call it smush, into one fraction. So this becomes, coefficient is now a 30, x to the 5th, y to the 3rd, over 20, x, y to the 4th. Alright, hopefully I didn't just ruin this video. Sorry guys. Alright, so we're back, number 10. Oh no, we're back on number 9. I didn't finish this problem yet. So now that we have smushed this together, these coefficients, these x's, and these y's can all reduce. So 30 over 20, that is a monomial coefficient that reduces to 3 over 2. And then x to the 5th over x to the 1st, if I subtracted those exponents, would be x to the 4th up in the numerator. And then y to the 3rd over y to the 4th will be y to the 1st, but it's down in the denominator because it's 3 minus 4, so negative 1 gets flipped down here. So you can put a 1 if you want, but this is my final answer.
Anthony Hicks, please report to the guidance office. Anthony Hicks to the guidance office, please.
Let's skip around a little on this section. Let's do number 11 next. So same idea. I want you to smush this fraction set together. So this numerator gets pushed together, becomes a 60 x to the 5th y to the 7th. And then our denominator is, let's see, 36 x to the 2nd, y to the 4th. And I purposely line up my like terms so that way they can reduce nicely. Alrighty, let's see here. That's divisible by 6. More than that though, 12 maybe? Alright, so if I divide that by 12, that's a 5, and that's a 3. Good. X to the 5th over x to the 2nd is x to the 3rd, and this will be y to the 3rd. Alright, so our answer is 5 over 3, and then we still have x to the 3rd in the numerator, and y to the 3rd in the numerator as well. Alright, so simplifying monomial multiplication is kind of interesting just because basically you smush the problem together before you can reduce. I think that's the easiest way to do them. Now when we get to number 13, this is it's very different because we don't have monomials, we have polynomials this time. So we have to first put parentheses around everything and then realize, and this is a monomial down here, but we'll worry about that in a minute, we have some factorization we have to worry about. So let's factor everything and then we'll see all the pieces that we're working with. 4x minus 4x squared. We have to use an advanced factoring technique where I feel like it's backwards. I don't like that the lead term is technically negative because it's in backwards order. So instead of just factoring out a 4x, I'm going to factor out a negative 4x from that expression. And then right here, if you took out a negative 4x, this would become a negative 1, and this would become a plus x. So if I reverse the order of that, you have x minus 1. That was a little confusing. I really don't think I'm ever going to ask you to factor out a negative on a test, so don't panic. I just gave that to you for SAT prep. X squared plus 2x minus 3, that guy factors nicely into, how about x plus 3x minus 1? Don't cancel anything yet. I know there is one, but hang on. Alright, this next numerator here, x squared minus, plus x minus 6, is going to factor into x plus 3 times x minus 2. And then the 4x is just a monomial. You can call them pieces if you want. I'm just going to leave it like this for now because I noticed there's another 4x right here. Alright, now for the fun part, we get to cross stuff off. So, 4x, gone. But be careful, there is still a negative right there. X minus 1 is gone. X plus 3 is gone. So, up in my numerator, I still have a negative. I still have the quantity x minus 2. And there's nothing left in the denominator, so if you want to put one, you can say a 1 or not. You can also distribute the negative and say it's negative x plus 2, but I actually prefer this answer. I want you to leave your answers in like all factors because it's easier for me to grade, frankly. Alright, taking a look at number 14 here. This is going to factor. This is going to factor a little. And this is going to factor. This guy's a monomial, so he's stuck. Alright, so we have x plus 3 times x minus 2 over 2x squared, and we'll leave that one alone for a minute, times, the 2 can come out of that guy, so 2 times x plus 4, over x plus 3 times x plus 4. And then we're going to cross cancel everything we can. So x plus 3's cancel, x plus 4's cancel, and then the 2 is going to cancel.
Good morning, Dad.
So we are still left with x plus 2 in the numerator and then an x squared in the denominator. And that's exactly what I'm going to write down. And because I'm always worried about you guys canceling things that don't cancel, I'm also going to put parentheses around the x plus 2. So that way we see there are no extra twins, and that is the answer. Excuse me. Alright. So these questions look really complicated. But the only thing that's going to factor in this problem is this binomial right here. So this is a more advanced factoring pattern, but it is the difference of two perfect squares. So the factoring pattern I'm referring to is the one where you have a squared, or a to the third minus b to the third, and it factors into a minus b times a squared plus ab plus b squared. So figuring out who a and b are, that's the challenge. So. Alright, a would be the cube root of this, so that'd be a 2x. Cube root of that is 1. And then 2x squared, quantity squared, would be a 4x squared. plus a times b, which would be 2x, plus b squared should be a 1. So that's what this first fraction really is. And then we're multiplying it by this existing 4x squared plus 2x plus 1. So, something kind of awesome. You should notice those are gone, which was the bulk of the problem. So all I have left in my numerator is x plus 3 divided by 2x minus 1. Awesome. So a good refresher of some factoring patterns that maybe you guys want to ignore, but you shouldn't. I think we have a similar thing happen here for the 27x to the third plus 8. Instead of having the difference of two squares pattern, that one uses the sum of two squares, or cubes. Gosh. Good night, Abruzzo. You need a nap. Except it's morning, so that's a little sad. Alright, so if I'm going to factor this guy using the sum of two cubes, that factors into 3x plus 2. And then 9x squared minus 6x plus 4. Now there already was an x plus 2 up here. And then off to the side, what do you know, there was a 9x squared minus 6x plus 4. So very deja vu-y of us, wasn't it? These guys are going to cancel. Gone. So all we're left with is x plus 2 over a 3x plus 2. Again, nothing cancels because this is a term and this is a term, and twins are not there, so nothing cancels. Alright. So now we're going to go back and think about how we divide fractions. You actually don't divide fractions. You change it to a multiplication problem by taking the reciprocal of the second fraction. So what I'm going to do is I'm going to multitask. I'm going to flip and I'm going to factor as I rewrite this. So 5x stays, that's a monomial. 3 times x minus 4 is the factorization for that guy. This is now a multiplication sign. And then remember, these are flipping. So this is now the numerator, and it factors into x minus 4 times x minus 2. And then, oops, this is my denominator now. I see a common x we could take out. Alright, so now for the fun times of cross-canceling. I see an x minus 4 and an x minus 2, and then this x and this x will cancel. And all we have left is a 5/3. So sometimes that happens. Sometimes everything cancels and you're just left with a 1. Alright, oh boy, there's a lot of factoring going on this next one. Ready? Hope you take a deep breath before we do this one. Alright. I'm so sorry. Factor out a common 5x here. And that leaves me with x plus 2. Keep going. Let's factor out this one. So that would be x minus 3 times x plus 2. And then we are flipping this to a multiplication problem. So this factors, and now it's in the numerator, into x plus 3 times x minus 3. And then this last one here, 15x to the third plus 45x squared. There's a common 15x squared we could take out. So we are left with, let's see here, that would be an x plus 3. Alright, now for the fun part, cross-canceling. X plus 2's gone, x minus 3's are gone, x plus 3's are gone, and I do have more canceling to do, but if you don't see it, that's okay. Go ahead and write down what you have. We have a 5x in the numerator and a 15x squared in the denominator. So if you want to think about what you have to reduce still, the 5 over 15 is a 1/3. And then x to the first over x squared would be an x to the first, but it's going to get thrown to the bottom. So 1 divided by 3x is my answer. Ooh, yuck. Alright. Oh, I'm so sorry. Okay. I'm ill. Okay, one more time. Let's take a look at 13 here. That looks fun. And we're going to skip around. So, this factors. A little perseverance on our part. We're going to get that to factor. Let's see. How about 3x and 2x? I'm sorry. How about a +3, because that'll give me a 9 on the outside arch. And a -1 right here, because that'll give me a -2. So 9 minus 2 is going to give me 7 in the middle. There we go. And then we have a 6x squared. This is now going to be a multiply. And then this fraction is going to reverse. It's going to get the reciprocal of that fraction, but let's factor while we go. So I can take an x out of there. That's not very exciting. 2x plus 3. Ooh, but the cancellation is very exciting. Let's take a look. 2x plus 3 is gone. And I guess that's it. So our numerator is 3x minus 1. And then down in the denominator, you have 6x times another x. 6x squared times another x. So you have 6x to the third. So again, that's a number. This is a monomial. I don't see any pieces or twins that cancel, so we're done. Alright, skip along with me. What if we put our thoughts together? What if we have some multiplication and division all in the same problem? It doesn't change anything. Anything that follows the division sign, we're going to have to change to a multiplication by creating a reciprocal fraction. So, factor and flip and rewrite all at the same time. Here we go. Everything here is factored, so x times x plus 5. Leave it alone. I am going to add parentheses, though. 3x minus 5, there's no factorization there. But what I am going to do is make it a fraction, so I can be careful who's in the numerator and who's not. And then this fraction, remember, flipped. X plus 5 is not going to factor, so just write it with parentheses. And the only thing that we can factor in this problem is 9x squared minus 25. That is the difference of two squares. So that factors into 3x plus 5 times 3x minus 5. And let's see what's going on. Gone. Gone. And that is it. So in my numerator, I still have an x. In our denominator, you still have a 3x plus 5. Nothing cross-cancels because 3x plus 5 is its own number. There are no twins, no monomial pieces that cancel, so that is our answer. Alright, I'm just going to scan ahead a little bit here. You know what? Let's do 16 because it looks like a really good time. Alright. Maybe if I don't croak from pneumonia, apparently. Ugh. 2x squared plus x minus 15. That factors into, I know it's 2x and 1x. Let's see, what if we did a plus 3 and a minus 5? Because that would give me 6 minus 5 on the arches. Yes, that would work. You have to triple check your factoring. If I do it wrong, I just like busted the rest of the question. Alright, this is going to factor as well. Let's see, 2x and x, got that. I know it's 7 and 3. What if we do a minus 7 and a plus 3? Because that'll give me a negative 14 plus 3 on the arches. Awesome. Now this middle piece, even though there's parentheses around it, still look for factoring. There is a common factor of 3 we could take out of there. So that gives me 2x plus 3 still. Put it over 1, that way we can keep track of the fraction. And then this is division, so to flip it to multiplication, we need to take the reciprocal. And again, we got a factor. This new numerator has a common 3 to take out. And then the denominator didn't have anything to factor, so I'll just write 2x minus 5. Alright, now for the best part of the problem. Let's see what goes. Gone. Gone. I'm so sorry. 2x plus 3 is gone. And there's nothing left in my denominator besides a 1, but in my numerator I have an x plus 3, I have a 3, I have another 3. So to make it look a little better, I am going to multiply those 3's together and write a 9, but I'm going to leave the rest factored. 9 times x plus 3. That's how I'm going to write my final answer. If you wrote 9x plus 27, you're totally fine. I just don't appreciate you guys multiplying things back together at the end of these problems. That's all. Take it or leave it, I guess, you know? Alright, so that's our lesson on multiplying, dividing, and simplifying monomial and polynomial expressions. Factoring, it's back, man. So there's a reason why I attacked you with factoring over the last 6 months. Alright, best wishes to you. We have some lessons coming up that might challenge you a little bit. We're going to be adding and subtracting fractions. And then also solving equations. Okay. More factoring. Yay!